Assalamualaikum and good day everyone. So in this video I'm going to explain on how to solve even function. Okay, so let's consider this example here. You are given a periodic function f(x) which is defined as f(x) is equals to 0, 4 and 0 for each of these following range. Okay, so for the first question you were asked to sketch the graph within the range of -3 pi until 3 pi. Then based on this graph, identify whether the given function is odd, even or neither, and state a reason. Okay, so as you can see in this periodic function here, your f(x) is all in terms of constant. Okay, so you don't need to do the table of coordinate. Okay, so you can directly sketch the graph. Okay, so for the first function here, you have a value from negative pi until negative pi over 2, which is from here until here. Your f(x) is always 0, so therefore you will have a straight line. Okay, so you will have a straight line here, 0. Okay, the next one is from negative pi over 2 until pi over 2, which is from here until here. Your f(x) is always equals to 4. Okay, remember I told you before, when you have a constant you will have a horizontal line or straight line. When you have a variable x, then you need to construct table of coordinate for you to know the point. Okay, so for this one here, between negative pi over 2 until pi over 2, which is here, your f(x) is equals to 4. So you know that. So between negative pi over 2 until pi over 2, so your f(x) is equals to 4. Okay, so the last one here, from pi over 2 until pi, which is here, again your f(x) is equals to 0, so you will have a line on the x-axis. Okay, so therefore you will have this line. Okay, so this is your first function. Your second function, this is your second function, and this is your third function. Okay, so now the graph will repeat itself after a period of 2l. So in this case, after a period of 2l, so after here, this period of 2l. Okay, so as you can see, the last point for graph number 3 is here. So this one will be the first point for the new graph. Okay, so therefore you will have another straight line here. Okay, the next one is, so take a look at the second function here. The range here is 2, 1, 2. This is 1. Okay, half and half. Okay, so you will have another half here and half here. Okay, so therefore you will have a straight line starting here until pi over 2, 5 over 2 pi. Okay, so you will have a point here, and the second one is here. So this is your straight line. Okay, so the last one is this one. So the range is half, so which means from 5 over 2 pi until 3 pi. Sorry, this is 3 pi. Okay, so you will have another straight line on the x-axis. So you will have this one here. Okay, so on the other side, which is on the left hand side, you need to start with the number 3 first, 2 and 1. So you will have 3, 2 and 1. Okay, so therefore you will have a graph which look like this one. This one here. So the second one will be from here until here, another straight line, and the last one is here. Okay, so as you can see, this is your original graph. So the graph repeats itself after a period of 2L. Okay, so sometimes you might have a complete new graph on your right hand side and a complete new graph on your left hand side, but sometimes it's just half of the graph. Okay, so it's all depends on the question here. So if you're asked to sketch from negative 2 pi until 2 pi, let's say, so therefore your graph is just up until here. Okay, so you need to refer to this one. So based on this function, based on the graph here, as you can see, the graph here is symmetrical about fx axis. So this is your fx axis. So when you have here, then you have another one here. When you have this one here, then you will have another one here. Okay, so therefore this is an even function. Why? Because it is symmetrical about fx axis. Okay, so therefore this is an even function. So the next one is find its Fourier series expansion for the given function here. So as you can see, this is an even function. So from here, from 0 until L here, you have this one graph, this one, and this one. Okay, for the left hand side, you have the same thing. When it is symmetrical about fx, okay, symmetrical about fx, when you have here, so you have another one here. So take a look at the formula here. For you to find the Fourier series for an even function, the formula is 2 over L, from 0 to L. Why this one start from 0 to L? For the previous function, which is a neither function, we start from negative L to L. But for even function, since it is symmetrical about fx axis, so you can just consider the positive part, then multiply by 2. So that's why we start from 0 until L, because the graph on this side is just equal to the what you have on your right hand side. Okay, but when we deal with the neither function, as you in the previous note, as you can see, when you have a graph, let's say this is your graph, this one and this one, so this is a neither function. That's why you need to consider from pi and negative pi until pi. Why? Because it is not symmetrical, so you need to consider this function and also this function. Okay, but when you deal with an odd or even function, since it is symmetrical, okay, as for this one, it is symmetrical about the fx axis. Okay, so therefore you can just consider the positive part of this one, then multiply by 2. So that's why in the formula here you have 2 over L, not 1 over L, and here start from 0 until L. Okay, so let's try to solve this one. So since you know that it is an even function, another clue for you is that your Bn is equals to 0. So you don't have to calculate your Bn. If you calculate your Bn, you will get this value. So therefore no need to calculate for your Bn. So just state your Bn is equals to 0. What you need to calculate is your A naught and also An by using this formula. Okay, so the same step as before. When you want to calculate the Fourier coefficient here, what you need first is your L. You need to define your L, and I already told you, you can just take the higher limit here as your L. Okay, so therefore you know that your L is equals to pi. Okay, so what is your A naught? So your A naught is equals to 2 over pi. So integrate from 0 until pi fx dx. Okay, so take a look at this one here, 0 until pi. Okay, so this is your pi. Now you need to find where this value 0 refer to which function, either this one or this one. So if you cannot get through this graph here, through the function here, take a look at your graph here. Okay, the original graph here. Where is the graph such that your x is equals to 0? Okay, so this is x is equals to 0, right? So which means that it's referred to the second function. Okay, remember we are going to integrate from 0 until L. So which function is included in x equals to 0? The second function. Okay, and as you can see, for the second function, the lower limit is negative pi over 2. The upper limit is pi over 2. But based on this formula, you know that you need to start from 0. So therefore, you will have 2 over pi. So you need to start from 0. Okay, and take a look at the second function here. The upper limit is pi over 2. So you will have pi over 2. So what is your fx here? Your fx is equals to 4 dx plus, so the lower limit is pi over 2, the upper limit is pi. Okay, so in this case, your fx is equals to 0. Okay, so be careful, check first. So you need to integrate from 0 until pi. So this is your lower limit and this is your upper limit. And I already told you before, you need to make sure this one is equals to this one. So in this case, this is correct. Okay, then only you proceed. You need to make sure this one is correct, because when you want to get your an afterwards, just use from here. Okay, don't need to separate again, just use whatever you have here. Okay, then just multiply with cos or multiply with sine function. Okay, so in this case, this one here you have 0, so totally this one is out, 0. Okay, so therefore you left with this one. So integrate 4 will give you 4x pi over 2, 0. Therefore this one is equals to, so 2 over pi. So substitute when your x is equals to pi over 2, then you will have 2 pi minus 0. So therefore you will have 4. Okay, so settle with your A naught. So next you need to calculate your an. So your an is equals to 2 over pi, negative 0, pi over 2. So what is your fx? Fx is equals to 4. Next one is you need to multiply by cos n pi x over L. So you will have, so you will have cos n pi x over L. So what is your L? Your L is equals to pi dx. Okay, so for this side here, since this one is equals to 0, so you don't need to plus, okay, because when you have a function fx 0 multiplied by cos, then you will also get 0, so you can just ignore this function. Okay, so take a look at the one in bracket here. So can you cancel out this one and this one? Yes. Why? Because this is in the same bracket here. Okay, so when you cancel out this one, so you left with 2 over pi. So integrate 0 pi over 2 4 cos nx dx. Okay, so integrate cos will give you sine. Okay, 4 is a constant, so you can just factorize this 4, so you will have 8 over pi. Okay, so integrate cos will give you sine nx over n, pi over 2 0. Okay, this n and this n you cannot cancel out because this is not in the same bracket. Okay, so substitute upper limit minus lower limit, so you will have 8 over pi 1 over n cos n pi over 2 minus 1 over n, oh sorry, this is sine, minus 1 over n sine 0. Okay, so you know that sine 0 is equals to 0, so therefore this one done. Okay, so you will left with 8 over n pi sine n pi over 2. You cannot cancel out this one and this one. Why? Because this is in bracket. Okay, so can you simplify this one so that it's become 0? Cannot. Okay, it will just be 0 if you have sine n pi or sine of negative n pi. This one is equals to 0. So if you have n pi over 2, then leave it as n pi over 2. Okay, so now you already have your A naught, you already have your an, and you know that by using these properties, Bn is equals to 0. Okay, so therefore, what is your Fx? So by using this formula here, your Bn is equals to 0, so this one cancel out. So you left with this one. Okay, so therefore you will have your Fx is equals to, so A naught over 2, since your A naught is equals to 4, so 4 divided by 2 will give you 2, plus summation of n is equals to 1 until infinity. So what is your an? 8 over n pi sine n pi over 2. So an cos n pi x over L. What is your L? Your L is equals to pi. So this one can cancel out. Okay, so therefore your Fourier series is given by Fx is equals to 2 plus summation of n is equals to 1 until infinity 8 over n pi sine n pi over 2 cos nx. That's it. Okay, because since this one is already become this one is already become 0 because your bn is equals to 0. So this one 0, that's why you left with only this one. Okay, if the question already told you that this is an even function, so you don't need to sketch, okay, because you already know that that is an even function, so you can just proceed with this formula. Okay, but if you don't know whether the function is odd, even, or neither, then you need to sketch first. Okay, so in my next video I will share with you another example on how to solve an even function. Thank you.